previously looked at problems where it said find the probability when you know that x bar, the mean from some sample, is less than some value. So now we're going to look at, in a sense, the reverse problem. So in this case, we're going to be given the probability, and we're going to have to find the data value, which in this case is going to be some x bar value. So let's look at what a question like that might say and how to do it. So a population has a normal distribution with mean mu equals 34.2 and the standard deviation sigma is 5.8. So if you take a sample size 32, the probability it will have a sample mean less than some value is 0.02. What is that value? First of all, what is this question asking? Well, what it's saying is the probability. So again, the question is about a sample mean. So that's x bar is less than some value. I'm just going to put a question mark there. That probability is 0.02. And obviously we're trying to find question mark, what is that value? So this is the question. Now let's write down some of the givens. They're written right there. We'll just recap them. We know that mu equals 34.2. We know that sigma equals 5.8. And we know that the distribution is going to be normal. However, notice that because we are taking a sample mean, we are not interested in the distribution of the population. We're interested in the distribution of the sample mean. So because that's the case, we are going to need sigma x bar. That's the standard deviation for the distribution of x bar, distribution of the sample mean. And then we find this, of course, is sigma divided by the square root of n, and n is the sample size, and that was given to be 32. So we know we're going to need this. And I'll just pull out a little handy dandy calculator. I'm going to use Excel as my calculator. 5.8 divided by the square root of 32. So that's this number, 1.0253. And again, because the population is normal, the distribution of x bar is also normal. Okay, so we figured out what the question is, and we wrote down the givens and also some additional things that we're going to need. Now, let's draw a graph to orient ourselves with the situation. So again, it's a normal distribution, so here's the normal curve. Every normal distribution has a z-score, and the particular distribution we're interested in is the distribution of x bar values. So we know that for z, we always have 0 in the middle, and for x bar, we know that the mean is 34.2. So now we're told is that there's some value, so the probability of being less than that is 0.02. So that's that area right there. And what we're being asked is, what is that particular x bar value? That's the thing that we need to find. So what do? In this case, we have to do what I like to call going down the ladder. We've got an area value. We've got to convert that to a z-score. Then we take the z-score and convert that to an x bar value. So those are really the two calculation steps. So first, what is z? So there's where you have to use your technology since we're converting from an area or probability value. So there's a couple ways to do it. My preferred way is StatDisk. So let's take a look. So distribution, normal distribution. In this case, what we know is the area from the left, which is 0.02. Click Evaluate, and there's your z-score. Negative 2.11. I always like to use 4 decimal places, negative 2.0537. Now, I don't necessarily encourage you to use Excel, but if you are using Excel, equals norm sinv of 0.02, and there's your z-score. Okay, so now that we've got the z-score, just to be complete, I'm going to fill that in on my graph. So now we have to find the x-bar value. So there's 2 different equivalent formulas we can use. So one that we've been using so far, so first we define z, and now we have to find x-bar. So we could use the usual formula, z equals x-bar minus mu for x-bar over sigma for x-bar. That's the formula we'd been using previously when we needed to go ahead and find a z-score. Now in this case, we know z, but we're trying to find x-bar. So what would be sort of more helpful for us is to turn this formula around and get x-bar equals blah, blah, blah. So first, we're going to multiply both sides by sigma x-bar, which is going to give us z times sigma x-bar. And then we're going to move the mu to the other side by adding. So what you wind up with is mu for x-bar plus z times sigma for x-bar, and that equals the x-bar value that we are interested in. So again, you can use either one of these formulas. It's easier to use the second one. So let's plug in. We know that mu for x-bar is just the same as mu. That's 34.2. We know the z-score was negative 2.0537. And sigma for x-bar, we previously figured that out, 1.0253. And now just do a little arithmetic. To do this, I'll pull up my calculator. Minus 2.0537 times 1.0253. And there's the answer, 32.0943. And that is the mystery x-bar value, and that's the answer to the question. So notice that in this problem, we were given, just to roll back for a sec, we were given the probability, and then we were asked for the data value. So that's 2 steps. You have to convert the area or probability into a z-score. Then you have to convert the z-score into your data value. In this case, data values are x-bar values.